Page 304, question number 2. Cannon A fires a 1.5 kilogram ball with a muzzle velocity of 550 meters per second. So we've got two cannons, A and we have cannon B. So A has a mass of 1.50 kilograms and a velocity of 550 meters per second. Cannon B fires a ball with 1/3 the mass. So if it's got 1/3 the mass, it'll be 1.50 kilograms divided by 3 and twice the muzzle velocity. So our velocity will be double 550 meters per second. Which of these two cannons would be more effective in damaging the fortification, and explain why? So we need to figure out the kinetic energy in both cases. So our kinetic energy is mass times velocity squared divided by 2. So we have 1.50 kilograms times 550 meters per second squared divided by 2. So 1.5 times 550 squared divided by 2 gives us 226,875 joules. And figuring this out for B, we have E equals mv squared divided by 2. So we have a mass of 1.50 kilograms divided by 3. We have a velocity of 2 times 550 meters per second, all squared, all divided by 2. So 1.5 divided by 3 times brackets 2 times 550, close brackets squared divided by 2 gives us 302,500 joules. So from this we can see cannon B has more energy. Now we don't actually have to do the entire calculation of A and B to determine this answer. We can figure it out using a ratio. If we look at our equation, kinetic energy is mass times velocity squared divided by 2. We know that our original value is 1. 1 for the mass, 1 for the velocity effectively. If we are going to put in 1/3 the mass, so 1/3 the mass and double the velocity, which we have to square, then this will show us what the ratio is. So if we go 1 divided by 3 times 2 squared, we're going to find that we have 1.3 repeating times more energy. So B is going to have 1.33 times as much energy as we do in this case. We don't need to divide by the 2 because that's a constant value and it shows up for the calculation in A and the calculation in B. So we're just interested in what do our variables do in this equation. So mass is proportional and velocity is the square proportional.